So yes, you can see Unacademy produced 7 trackers in top 20, 15 trackers in top 50, and 170 plus Unacademy also cracked it. We can go through the slide. And there is 35% offer going on, 20% is optional, plus 10% if you use my code Prasanna10. And there is also 9 months combo to crack UPSC Prelims 2022, 28% off with optional, plus 10% if you use my code Prasanna10. And you're going to get a series for free if you purchase 1 year subscription. And there's also 3 month festive combo, 10% with optional, plus 10% if you use my code Prasanna10. So this is a new batch starting on 3rd November. And this is scheduled for 1 year batch. And these are the educators. And this is scheduled for 2 year batch. And these are the educators. So there's also a free test series for UPSC CSE. And this is a client mentorship program. And you can also avail loan if you want, right? Yes, we'll get into the problem now. Problem. Solve root of 1 plus x squared dy minus x into root of 1 minus y squared dx equal to 0, right? This will be same as root of 1 plus x squared dy is equal to x into root of 1 minus y squared dx. Now we'll separate y and function of we will separate dy and function of y to one side. We will separate dx and function of x to other side. So we will have dy divided by root of 1 minus y square is equal to, so we will keep this x dx as it is. We will bring this term to this side. So we will have root of 1 plus x square, right? So integrate. So we will have integral dy divided by root of 1 minus y square is equal to integral x dx divided by root of 1 plus x square, right? So these are very basic formulas. So integral root of 1 minus y square is nothing but sine inverse of y. So this will be equal to sine inverse of y. Now what is integral x dx by root of 1 plus x square? So always remember, whenever you have like this, so if you differentiate inside, what you will have? We will have 2x, right? If you differentiate this inside, you will have 2x. So but here we have only x. So what I'm going to do is I'm going to multiply by 1 by 2, and I'm going to I'm just multiplying by 2, right? So you will have root of 1 plus x square dx. Now this I can write this as, so this implies my sine inverse y is equal to 1 by 2. Now I'm going to write this term as 1 plus x square whole power minus 1 by 2, 2x dx, right? 2x dx. So if we integrate this, what you will have? This will be equal to sine inverse of y. So 1 by 2. So this will be equal to 1 plus x square whole power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. You don't need to integrate by uv dx, uv dv, right? Because the derivative of inside term is here, right? That means you can integrate this directly, and you don't need to differentiate inside, right? Usually if I differentiate this term means, suppose for example, usually if I integrate only this term means my integration will be this into, we will differentiate inside and we'll put in the denominator, right? But we do not need to do that because already 2x is here, right? Yes, so this is same as this. Now this 1 by 2 and this 1 by 2 will get cancelled, right? So we will have sine inverse of y is equal to, this is what, root of 1 plus x square plus c is the required solution, right? Or you can also use the formula that integral x by root of 1 plus x square dx is root of 1 plus x square. This is a basic formula that you come across in school level, right? So using some substitution like tan theta, secant theta, they will prove this. So we don't want to do that, right? We will do this directly. So whenever you have you just differentiate inside, you see what it is 2x. So you just integrate, you just make 2x here and integrate with respect to 2x dx, right? Yes. We'll move on to 23rd problem. So solve e power x root of 1 minus y squared dx plus y by x dy. So this is same as e power x into root of 1 minus y square dx plus y by, okay, we will write this as, so we will make some space. Okay, solution. So this is equal to e power x into root of 1 minus y square is equal to minus y by x dy. So if I cross multiply this, we will have x into e power x into root of 1 minus y square is equal to minus y dy. Now you separate x dx and y dy. So we'll keep this x e power x as okay, where it is dx, sorry, I missed it, dx. So we have e power x into root of 1 minus y square dx is equal to minus y by x dy. So cross multiply this, we will have x into e power x into root of 1 minus y square dx is equal to minus y into dy. Now you separate x dx and y dy. So we will keep this x e power x dx as it is. Now let us bring this y term here. So minus dy divided by root of 1 minus y square, right? You just have to integrate now. So integral x into e power x dx is equal to minus integral y dy divided by root of 1 minus y square. Now again you just apply the same that we did here. So here we have plus, so if I differentiate inside means you will have plus 2x. Here we have 1 minus y square. If I differentiate inside means we will have minus 2y. So make sure that you have minus 2y here, right? That means what I'm going to do is, already we have minus here. So what I'm going to do is, I'm just going to write this as, okay, let me write here. So x into e power x. So you just need to apply uv method, right? So let us take u to be equal to x, v to be equal to e power x. It will be uv minus integral v du. And what I'm going to do is, I'm going to divide by 2 and let me write plus here, and I'm going to write this as minus 2y dy divided by root of 1 minus y square, right? So this will be equal to, so here my u is x, v dv is e power x. So that means my du is equal to dx, my v is e power x again, right? So apply the formula uv minus integral v du is equal to this. I'm going to write this as 1 by 2 integral 1 minus y square whole power minus 1 by 2 minus 2y dy, right? In the previous problem we have same pattern. Here we have plus 2x dx, means you just have to integrate only this term. You don't need to differentiate inside and put it in the denominator, right? So my u is x, v is e power x minus integral v du. I'm just doing two. Here we have one function, here we have one integration, here we have one integration. This integration very easy, it is nothing but integration by parts. So uv minus integral v du. This I am making some simplifications, right? So this will be e power x into e power x minus v du. So v is e power x, du is dx. This will be equal to 1 by 2. So what is the integration of this? This is nothing but 1 minus y square whole power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. You don't need to differentiate inside and put in the denominator, right? Because already you have minus 2y dy here. This is equal to x e power x minus e power x. So this 1 by 2 and this 1 by 2 will get cancelled. So this will be equal to plus 1 by 2, right? So this will be equal to root of 1 minus y square. So if I take e power x common, so we will have x minus 1 is equal to root of 1 minus y square, right? So is the required solution, or if you want you can also add some integration constant, is the required solution. So whenever you have like this, right? So whenever you have integral y divided by root of 1 plus y square or integral y divided by root of 1 minus y square, you apply this method, right? This will be easy for you in exam point of view, right? You can also find some other method by some substitution, but it will take time. You always prefer this method, right? Here you can see we have integral x by root of 1 plus x square dx. So here if I differentiate it inside, we will have 2x. So make sure that you have 2x here. So I'm multiplying 2 by 2. So that means I'm going to integrate this. So you integrate this, you just integrate this term. And the important thing is you don't need to differentiate inside and put it in the denominator because we already have 2x here, right? Yes. So we'll move on to problem number here you can see 23rd problem is also same, right? So here we have minus y divided by root of 1 minus y square multiply 2, so that we will have minus 2y. So multiply 2 by 2. Already we have minus here. So this is same as integration of 1 minus y square whole power minus 1 by 2. You don't need to differentiate inside, right? Whenever you have minus 2y, because here if you differentiate here you have minus 2y, right? You don't need to do that. These are just 11th standard school, 11th and 12th standard integrations, right? So we move on to 24th problem. So solve x d square by dx plus y is equal to 1. So x square dy by dx is equal to 1 minus y. So we have x square dy is equal to 1 minus y dx. So you just separate y and x terms. So we will have dy divided by 1 minus y, and here we have dx divided by x square. Now integrate. So this, now we know that integral f dash of x, right? Integral f dash of x divided by f of x is log of f of x, right? Now here we have 1 minus y. So if I take this as f of y, my f dash of y is minus 1, right? But here we have plus 1. So what we will do is we will multiply minus 1 by minus 1, right? We will multiply minus 1 by minus 1. Write this as dy divided by 1 minus y, and this is nothing but integral x power minus 2 dx. So I'm taking 1, I'll keep 1 minus 1 here, I'll keep 1 minus 1 to, I'll take 1 minus 1 to inside. This will be equal to x power minus 2 plus 1 divided by minus 2 plus 1. Now you can see I can apply the formula integral f of x f dash of x, right? So this is minus, this is log of f of x, which is log 1 minus y, and this is equal to minus 1 by x, right? Here we have x power minus 1, here we have minus 1. So we will add some constant c, right? Is the required solution. Is the required solution, right? It's a very easy problem. So whenever you have f of x, f dash of x, you just write log of f of x. So here we have 1 minus y. So by differentiate we will have minus 1, right? By differentiate this will have minus 1. So here in terms of y, right? Here in terms of x, in terms of y, no problem. So differentiate this, you will have minus 1, but here we have plus 1 here. So if I make this as minus 1, I can use this formula. So I'm multiplying dividing by minus 1, and I'm taking 1, I'm keeping 1 minus 1 here, and I'm taking 1 minus 1 inside. So I can apply the formula log of 1 minus y. We will have minus 1 by x plus c, right?